Okay, so let's take a look at section 2.5. In this section, there are several graphs, like families of functions, the graphs for, I call them parent graphs sometimes, that I want you to be familiar with. Some of these we've already seen, some you may have seen in high school. So if you've downloaded the notes for section 2.5, I'm on the first page there where it gives you 7 different functions, and it lists the parent equation first. So we start off with f of x equals x. Of course, remember f of x and y can be used interchangeably, so this is the same thing, it's just y equals x, which hopefully by now you recognize as the equation of a line, and that's a line that goes through the origin. So here's sort of the basic parent graph. It goes through the origin, has a slope of 1. So the function family for this would be linear, so that's just a basic linear function. The next picture, f of x equals x squared. Of course, you could also think of that as y equals x squared. That's the U-shaped graph that goes through the origin. And if you've heard of that before, you may have heard of that before, the graph is called a parabola. We'll get more into that in the next chapter, but the function family is called quadratic. So that's the family of quadratic functions. The next one in your picture, f of x equals x cubed, or y equals x cubed. Looks like this. It goes through the origin, goes up on the right, down on the left, and that would be the cubic function family, because x to the third, of course, is x cubed. The next one, f of x equals absolute value of x, or y equals absolute value of x. Looks like this. It's a V shape going through the origin, has a sharp point at the origin. That's our absolute value family. And then the next one, f of x equals square root of x. Of course, y equals square root of x. It looks like this. They all go through the origin for the parent graphs. Starts out at the origin, goes out to the right. There's nothing on the left side of the graph, because on the left side of the graph, the x's would be negative. And when we graph, we only work with real numbers. So it only includes positive x values, and that's the square root function family. And that should make sense because we can't take the square root of a negative number. So that's why it's only on the right side of the graph. Okay, number 6. This is similar to the square root function. This is y equals cube root of x. And I'm putting the y here. F of x and y, remember, the same thing. I just want you to know that. It looks like this. It goes to the origin again, goes up on the right, down on the left. You can take the cube root of negative numbers, which is why we have definition over here. So this is the cube root function. And then the last one, number 7, is y equals 1 over x. And there's a couple different names for this one. Some books call these hyperbolas, or the hyperbolic function. I believe our book refers to it as the reciprocal function. It's also called a rational function. It's a family of rational functions, which we'll study in chapter 3. But the graph of it looks like this. So it's defined in the first quadrant. It's got a vertical asymptote at the y-axis and a horizontal asymptote at the x-axis. And then it's also got definition in the third quadrant. So it's in different separated pieces like that. So the next thing I want you to be familiar with, I want you to kind of know those parent graphs, have an idea of what they look like, but then I want you to also know about different types of shifting and reflecting. So if a graph has a vertical shift, we would know, because y equals f of x, whatever the function family is, it would have plus or minus a constant at the end. So that shifts the graph up or down. Horizontal shifting we would know because it's got a constant inside the function. So f of y equals f of the parentheses x minus h. That shifts it left or right. And it's actually opposite. So we'll do an example of this in a minute so you can see it. But for example, if it was x minus 3, it would actually move it to the right 3 units. If it were x plus 3, it would actually move it to the left 3 units. That's the only one that's opposite that you have to worry about. Reflections, if there's a negative in front of the function, it's going to reflect it over the x-axis. If there's a negative in front of the x on the inside of the function, it's going to reflect or flip it over the y-axis. And then stretching and shrinking, we're not going to do a whole lot with these, but if you've got a coefficient, a number in front of the function, if that number is greater than 1, it causes the graph to stretch. It makes it a little bit skinnier. And then if it's a number that's a fraction between 0 and 1, say 1/2 or 1/3 or something like that, it's going to cause the graph to shrink vertically or be a little fatter or wider. So let's look at some examples. So you want to know what those parent graphs look like. Have that list in front of you so you can look at these and pause as you need to in the video. So the first one they want us to graph is the absolute value of x minus 4. So go back and take a look at what the absolute value function, the parent graph, looks like on your notes. And hopefully you see that it was that V shape that we talked about earlier. So I like to always graph the parent graph and the shift or the translation. So the parent graph, I'm going to do in like a dashed line going through the origin, that V shape. And then the -4, think about how that's going to shift it. It's on the outside, so it's going to be a vertical shift, and it's -4, so it's going to shift it down 4 units. So you're going to take that point at the origin, you're just going to go down 1, 2, 3, 4. Let's label that -4 so we know what's what. And then just going to take the same shape of the graph and draw it in. And there you go. The next one, identify the parent graph first. We've got the x² function. That's our quadratic family. So the parent graph is that U-shaped parabola. So I'm going to graph that first, going through the origin, kind of dashed here. And then this graph actually has 2 shifts. The one on the outside, the +2, that's your vertical shift. So that's going to cause it to go up 2 units. And then the 3, notice, is on the inside of the function, so it's going to be a horizontal shift. And remember, we said horizontal shifting is opposite, so it's -3. It's actually going to go to the right 3 units. So let's take that vertex, that point at the origin, and we're going to move it to the right 1, 2, 3 units, and up 1, 2. And that's our new locator point. Everything else about the graph stays the same. The shape and everything else is unchanged. It's just got that shift. Okay, number 3, first identify what function family this would be. You've got a square root, so it's going to be our square root function. Take a look at your handout. What does the square root parent graph look like? Remember, it goes through the origin and just opens to the right, like so. And then the +4, let's do that first. So we're going to, the +4 is on the outside. It's going to be a vertical shift, so we're going to go up 1, 2, 3, 4 units. And then how is the negative in front of the x going to reflect it? Go back and look up here. If the negative was in front of the x like so, it reflects over the y-axis. So let's do that. So I'm going to let's draw the graph with the shift first. Without the reflection, it would look like that. But then if we reflect this over the y-axis, it's going to go like so. And that's the graph that we want. Okay, number 4, we're back to our quadratic. We've got the parent graph, the parabola again, so let's start with that. Okay, and then think about what kind of shifting we have. The 3 is on the outside, +3, that's going to move it up 3 units. The 1 is on the inside, it's positive, so it's going to actually go left 1 unit. So let's go ahead and make that shift. So we're going to go left 1 and up 1, 2, 3, so that would put me there, 3 and -1. And then there's a negative in the front. So normally the negative would reflect it, since it's in the front, over the x-axis. So instead of opening up, it would make the parabola open down. It's still going to have that reflection. It's just going to do so from this point. And the 1/2 is going to cause it to shrink vertically. I'm not going to do a whole lot with this, but remember we said that means it kind of makes it a little fatter or wider. This is most obvious, I think, with the parabolas because it kind of makes it bow out a little bit. So it's opening down and it's going to be wider than everything else. And there's our new graph. Okay, so example 5, we've got, looks like it's the square root function family again. So I'm going to go ahead and draw the parent graph first. And then how is this going to shift? The 1 is on the inside and it's minus, so that means it's actually going to go to the right 1 unit. The 3 is on the outside, so it's going to go up 3 units. So we're going to take this point, we're going to go to the right 1 unit and up 1, 2, 3. And so there's our new locator point. Number 6, we have the cubic function family. So take a look at your handout. What did the cubic graph look like? Remember the parent graph? It went up on the right. So it's sort of like half a parabola on the right, half of a parabola going down. That's our regular basic parent graph for the cubic function. So this is going to shift left 1 unit, down 4 units. So let's do that first. We're going to go left 1 unit, down 1, 2, 3, 4 units. Now think about how the negative in the front is going to reflect it. Remember that reflects over the x-axis. So think about if you took the original parent graph and you reflect it over the x-axis, instead of going up on the right, down on the left, it would go up on the left, down on the right. So we're going to have the same thing. It's just going to be at this new locator point. So with the negative in the front, it's going to look something like that. Okay, and then the last example, it says example 5 again, I guess we're on example 7. It says use the graph to make the transformation. So there's 4 different transformations they want us to do. So let's do 2 on the first sketch and 2 on the second sketch. And this is not one of our parent graphs. It's just a generic function. They're calling it f of x, but they want us to show that we know what each of these translations mean. So the first one for letter A, we've got f of x plus 2. The x plus 2 is in parentheses. So think about how that's going to shift it. It's on the inside, so we know it's going to be a horizontal shift. And it's plus 2, so it's actually going to move it left 2 units. So here's what I want you to think about doing. Take all of the points that are sort of like key points. So like we've got 1 here, 1 here, 1 here, and 1 here. So we kind of have 4 key points that we can shift and use that to make our new graph. So I'm going to take all those points and I'm going to shift them left 2 units. So this first point is at -2, -1. So think about going left 2 units. And if you want to do it on this graph, that's okay. I'm going to put mine down here so it looks a little bit neater, but you can draw it right on here. It doesn't matter as long as you know what's what. So we're going to take this and go left 2 points. So that's going to put me at -4. Let's see, 1, 2, 3, -4, -1, I believe it put me right there. And then this point in the original graph was at -1, 0. So let's go ahead and shift that to the left 2 units. That'll put me at -3, 0. So there's the first little segment right there. This point was at 0, -2. So if we move that to the left 2 units, it puts me here at -2, -2. So that would be like the first little segment and the second segment. And then the last point up here was at 1, 2, it looks like. So if we move that left 2 units, that'll put me at -1, 2. So I think it's right about there. So that's our sketch of the function. That's part A. Moved everything to the left 2 units. Let's look at part B. So they want us to take the original graph and shift it how? This means we're going to shift it down 3 units. So take all 4 of these points and shift them down 3 units. So this first point was at -2, -1. If we go down 3 units, that's going to put me at -2, -4, I believe. Let's see. So -2, -1. Let's see. 1, 2, 3. I think it puts me right there. Let me make sure. Hold on. -1, 1, 2. Let's see. -1, 1, 2, 3. I'm sorry. I need one more. I had it in the wrong spot. -4. So let's make sure we got it. -2, -1 puts us at -2, -4. So make sure let me move this up so everybody can see it. That's the point right there we're talking about. The next point was at -1, 0. So if I shift that down 3 units, so -1, 0, go down 1, 2, 3 units, puts me right there. So let me go ahead and draw that first segment so we have that part. The next point, 0, -2, if we shift that down 3 units, it's going to take me off the graph here, but that's okay. So we're going to go 1, 2, 3, 4. I believe it puts me right there at -5. And then the last point was at 1, 2. So if we move that down 3 units, that's going to put me at 1, -1. So there it is. And so, whoops, I move that up so we can see it. That's part B with the shift down 3 units. Okay, part C, they want us to take it and reflect everything over the x-axis because there's a negative in the front of the function. So each of these points, if you reflect it over the x-axis, it's going to put it in a different quadrant. So -2, -1, that's going to flip up and put me in quadrant 2. So that'll put me at -2, +1. Let's draw that. Let's see, so here's -2, +1, so it puts me there. negative 1, 0. If I reflect that, it's not going to go anywhere. It's still going to be on the x-axis. So negative 1, 0 is still going to be there. 0, negative 2, if you reflect it, it's going to put it on the positive side of the y-axis. So it's going to be at 0, positive 2. So there's the first couple of segments. And then this last point, 1, comma 2, if I flip that, it's going to put me at 1, comma, negative 2. So 1, comma, negative 2. It looks like it's right there. So pause for a second and make sure you see that that's a reflection over the x-axis from the original function. So that would be part C. And then for part D, they want us to make the change. We want us to make the flip over the y-axis. So let's go back to the original function. Anything that's over on the left side, we're going to flip it to the right side. So negative 2, negative 1, that's going to reflect to positive 2, negative 1. So positive 2, negative 1 is going to be the first point. Negative 1, 0, that's going to reflect over here to 1, 0. 0, negative 2, if I flip over the y-axis, it's not going to go anywhere. So that's still going to be at 0, negative 2. And then 1, comma 2, if I flip over the y-axis, is going to put me at negative 1, comma 2. So I think it's up here. All right, let's make sure I think I've got all my points. Let's see. This one was here. And this one was here. Sometimes it's best to just do these on separate graphs. I know it's hard to see that, but that last one I just drew was the reflection over the y-axis. So try it on your paper and see how you do. In the homework in my math lab, they give you graphs to help you kind of figure out where these points go, and you just plot the points to see it, which I think is a little easier, or it might be a multiple choice question. So I think you can probably do these, but take a look at them in this section and just practice and let me know if you have any questions.